In plate tectonics, plate boundaries are the interesting places because that's where all the action is happening. If you're sitting right in the middle of a big tectonic plate, like in the Midwestern United States, there's not much happening, no earthquakes, no volcanoes, none of that is going on. But at the plate boundaries, that's where these things happen. So let's start by talking about the divergent plate boundaries, where two different plates are getting pulled in different directions. So this is kind of what a cross-section of the Atlantic Ocean would look like. And one way to think about this is if all the water was drained from the Atlantic Ocean and you decided to mountain bike from the eastern United States, let's say from New York over to Africa, you could do that if there was no water in, and your journey would look something like this. You would leave the continent and it would be muddier, but it really would still be pretty flat because you would be out on the continental shelf. And this would continue until you hit this big downward slope here, which is the continental slope and rise. And a lot of fishermen get beyond the continental shelf to get into this deeper water to fish. But then once you got down this giant hill, then you would be in this relatively flat area called the abyssal plain. And in the Atlantic Ocean, this would be the deepest part of the ocean, this and on the other side over here, not the middle of the ocean. And once you get out to this point here, then you would start climbing up this bumpy mountain ridge over here. And it would just keep going up and up and up until you got to the very top, where it would actually drop down into a small axial rift or rift valley. So there'd be kind of a low valley right at the top of this mountain that you just biked up here. And actually in that valley there would be some hot molten lava there, so you want to be careful about that. But once you get over the mountain, then you would bike down the other side, once again in a big flat area, go up the continental slope on the other side, finally a flat area, and then you would be on the continent of Africa over here. And that's just kind of what it looks like as we continue this conversation. And if we look at that on a map, the continents here are shown in black. The continental shelf is shown in pink. So here's the continent of Africa, the continental shelf in pink. And you can see there's the downward motion here, this big flat area. And then here's that mountain range that runs down the middle of the ocean. And here's Iceland here, runs all the way down through the middle of the ocean, kind of zigs and zags around, but it's right down the middle of the entire Atlantic Ocean. That's where the divergent plate boundary is. This is another map that kind of shows that same mountain range down the middle of the Atlantic in more of a 3D, and we can see it's going to be a bumpy ride, right? There's things, the shelf and the slope are pretty smooth, but once you get down here, there's actually a lot of little kind of bumps on the abyssal plains, the low part of the ocean, and then this middle part really is a mountain that would be hard to bike over if there was no water in the ocean. And right as you get to the top there, you might be able to see there's like that rift valley is right in the middle, kind of symmetrically, of this mountain range at the bottom of the ocean. This map was put together by the U.S. Geological Survey, and one of the people that helped put this map together and really helped us understand plate tectonics is Maria Tharp, and really a pioneer in this field and a woman to be recognized. And this is how a divergent plate boundary works. So you might start out with all continental material, but over time, think of Pangaea, right, the old supercontinent, but over time what happens is that there's some separation of the continent here, and then this warm material from the mantle starts welling up here. And this warm mantle material, it lifts up both sides. You can see this is a little bit higher than over here. And also, there's actually magma here. Magma is melted rock. So remember, the mantle is a solid, but just in this one area here, it's a little bit warmer, and that magma is melting. And as the magma melts, it would actually, along this rift valley here, you would actually start having magma flow to the surface, and that's called lava. And that lava is actually creating new rocks. So as this divergent plate boundary occurs over time, then these two sides of the continent go further and further apart. It's almost like each side of this is a conveyor belt where they're moving in two different directions here, and the newest material is being created right in this rift valley here. So new material created here, slowly, it moves out over time. The continents get further and further apart in both directions, and the rift valley stays right in the middle of the ocean. So you can imagine the oldest seafloor in this area is way out in this area here, and then you get into younger and younger seafloor as you move towards the Rift Valley. Same on this side, oldest seafloor here, and then younger and younger and younger as you move towards the Rift Valley. And here's another display of that, kind of more isolated here. We can see the lithosphere, in this case, thins up as we move towards the Rift Valley. It thickens as it cools. And this magma chamber is only located right below the Rift Valley. All the little red kind of splotches in there would be lava that's flowing at the bottom of the ocean, is flowing into these little cracks in the rocks. And the same thing happening on the other side. So here's where the magma chamber is, with the lava flowing to the surface, creating new seafloor. It's happening in both directions. And over time, you get the youngest ocean here and older oceanic lithosphere as we move out in this direction here. Same over here. The youngest oceanic lithosphere here, and older oceanic lithosphere as we move out in this direction here. Remember, all that movement is occurring along the asthenosphere as these two plates are pulled in different directions here.